Today we will start with the preparation of haloalkanes. Okay, so haloalkanes, as the name says, it has a halogen attached to an alkyl group. Okay, an halogen attached to an alkyl group. Its formula will be CnH2n plus 1 with a halogen, an alkyl group with an halogen. Now, how to prepare these haloalkanes? At first, we will start from the basics. That is, what the chapters that we have in our syllabus is mainly hydrocarbons. In the hydrocarbons part, we have alkanes, alkenes, alkynes. Okay. In the hydrocarbon parts, we have alkanes, alkenes, and alkynes. So at first, we will focus on preparation of haloalkanes from alkanes, alkenes, and alkynes. Okay. So this will be our first target. Okay. Secondly, we have to find that what are other chapters are there in our syllabus. In class 12, we have the first chapter is this one. The second chapter is alcohol, phenols, and ethers. So we also have to find the ways to prepare haloalkanes from alcohols, phenols, and ethers. The next chapter will be our aldehyde, ketones, and carboxylic acid. So accordingly, we will also see the ways of preparation of haloalkanes from aldehyde, ketones, and carboxylic acids itself. Okay, so this then we have amines, and then we have some other nitrogen containing groups like diazonium chloride or nitro groups. So this is the main thing. Why we are learning about the preparation? We are learning about the preparation because in most of the questions that will come in your exams will be of you have to convert from one type of molecule to the other. Suppose you have to convert an alcohol to a alkyl halide. So you need to know how to prepare that, what are the reaction that is responsible for the conversion. Secondly, when you are doing preparation, you have to bridge between different chapters. Like when we are doing for an amine, so we have to find out, so the reaction of an amine will be also studied in this part where we are studying the preparation, like alcohols to alkyl halides. Okay, or alkanes to alkyl halides. In this preparation, we are also learning about the properties of alkanes or properties of alcohols to form alkyl halides. Okay, it means the reaction of alcohols. What are the reagents that are used? So this is how we have to bridge different chapters of the whole organic chemistry segment, because in organic chemistry, everything is like a spider web. It is connected with each other. Okay, every chapter is connected with the other. So there is no way we can define anything. Secondly, we need to also learn about the physical properties like the dipole moments, the other properties like the boiling points. We have also already mentioned about the boiling point, melting points, and I have also given you the type. We have also discussed about the dipole moment part. I have sent you that. So now at first we will start with the first chapter, which is the hydrocarbons. From the hydrocarbon segment, we will understand how to prepare haloalkane. Okay. So firstly, our notice will go to the alkenes. Okay. Alkenes to alkyl halides. Alkenes to alkyl halides. Okay. Alkenes to alkyl halides. To state clearly that alkanes have a molecular has an structural formula, that is the main form is CnH2n plus 2. Okay, from here we will add X2 to give you CnH2n plus 1x and HX, and this will be assisted with H nu. Okay, this will be assisted with the light reaction. It is photochemically activated reaction. Okay, this is a photochemically activated reaction. If at any point of time you are feeling that I'm going a little fast, you can tell me, we can slow down, or I can change the language of the description. Okay, understood? কারোর কোনো প্রবলেম হচ্ছে না তো? হ্যালো, হ্যালো, Okay, so this is the reaction. যেখানে আমরা দেখতে পাচ্ছি CnH2n plus 2. So this is the general formula. From here we are going there. This is also linked with another chapter which is known as kinetics. So can you tell me what is the order of this reaction? Order of this reaction? Anybody? This is a photochemically active reaction, that is, it is light catalyzed reaction. So any light catalyzed reaction will always be of zero order. Okay, any light catalyst or any catalytic reaction will be of the zero order. So order of this reaction will be zero. It may come in your MCQs, okay, in JEE Mains or JEE Advanced. So order of this reaction is zero. So if you have C2H6 and you give here X2 or like Cl2, we give H nu, we will get C2H5Cl and HCl. C2H5Cl when treated with Cl2, they will get C2H4Cl plus HCl. Okay, now I'm just breaking the structure. Then C2H5Cl, this is CH3, CH2, Cl, this is Cl2. When treated with this one, you will be getting CH3, CH, Cl, and Cl. Okay, and this is the HCl. So the carbon which is attached to the halogen will again undergo halogenation. Okay, this is the thing that you need to know, that this is a radical reaction. All these reactions are radical reactions. Radical reactions. And this radical, the radical which has a higher, the radical which is attached to an electronegative fluorine, which has a vacant d orbital with it, will be more stable, and that is why the reaction will proceed through that carbon only. Okay, this is for alkanes. How can we prepare alkyl halide from alkanes? Now this next thing is alkenes to alkyl halides. অ্যালকেনস থেকে অ্যালকাইল হ্যালাইডস এর জায়গাটা সবাই বুঝতে পেরেছো? অ্যালকেনস থেকে অ্যালকাইল হ্যালাইডস এর জায়গাটা বুঝতে পেরেছো? হ্যালো, হ্যালো, ওকে। সো next thing is that alkenes to alkyl, তাহলে alkenes থেকে alkyl halides আমরা কি করব? Alkenes is nothing but this type of moiety CH2 একটা ডাবল বন্ড আছে। সো এটা কি রকম হতে পারে? It can be like this also, CH3CH double bond CH2. So আমরা এখানে ডাইরেক্ট HCl দিতে পারবো, and we will get the product as CH3 CHCl CH3. এখানে দুটো ধরনের প্রোডাক্ট হবে, একটা হচ্ছে সেডজেফ প্রোডাক্ট, একটা হচ্ছে হফম্যান প্রোডাক্ট। ওকে, this is more substituted product, এটার নাম হচ্ছে সেডজেফ প্রোডাক্ট, and this is হফম্যান প্রোডাক্ট। ওকে, যখন আমরা দেখছি এরকম আছে, আমাদের এখানে কি করতে হবে? স্টেবিলিটি নাম্বার লাইন, উই হ্যাভ টু ফলো দ্য স্টেবিলিটি নাম্বার লাইন, আন্ডারস্ট্যান্ড? Stability number line. So what is stability number line? যে কোনো carbon which is a charged carbon has a highest degree of 3. Okay, any charged carbon will have a highest degree of 3. So we will write here, if it is a carbocation, it will have a highest plus 3 degree. If it is a carb anion, it will have a highest of minus 3 degree. Okay, তাহলে কার্বোক্যাটায়ন হলে হাইয়েস্ট প্লাস 3 ডিগ্রি হবে, কার্বন হলে মাইনাস 3 ডিগ্রি হবে, and this is the increasing order. So here you will get the carb anions, Here you will get the carbocations. Also the radicals, carbon radicals. They will also follow the same order as that you are studying in the number line. Number line যেরকম আমরা দেখাচ্ছি সেরকম radicals stability দাও. Radicals will also follow the same stability. Now, when you are having this, suppose you are having this, you have to break this double bond. This is known as electromaric. Okay. So what will happen? You will see that you will have two types of structure. Either it will flow to this carbon, you will have a negative charge and a positive charge, or you will have this structure CH3, CH with a negative charge and CH2 with a positive charge. These two are the probable structure. So here you are having a 2-degree carbocation and you are having a 1-degree carbocation. So between 1 degree and 2 degree, which is more stable? Between 1 degree and 2 degree, which is more stable as a carbocation? You can go for the stability number line. 2-degree carbocation is more stable. So you will say that this will be more stable. And between carbanions, 1-degree carbanion and 2-degree carbanion, 1-degree carbanions are more stable. So you will state that this structure will occur predominantly. So whenever you are adding HCl here, H will be plus and Cl will be minus. So it will come here and it will attack to this. Major product from this reaction will be your ZF product. Okay, the major product from this reaction will be your ZF product. Now, if the same thing is given, but now the reagent has been changed. This was only HCl. Suppose you are giving HBr and H2O2 peroxide. You are also giving peroxide. So this is known as peroxide effect or Kharash effect. Okay, this is also known as peroxide effect or Kharash effect, and this will give you this product. Okay, it is a reversal of it is a radical product actually. The radical formation will occur through this structure and you will get this. So here you are getting this. This is also known as Markovnikov's product. Okay, this is also known as Markovnikov's product. This is also known as Markovnikov product. Okay, and this is anti-Markovnikov's product. Anti-Markovnikov's product. Okay, so why does this occur? Eta keno hoy? HBr when treated with H2O2, obviously it should also be light. It should be, you should use light. Okay, without light this reaction doesn't proceed. So you will get 2 OH radical from this H2O2, and this OH radical will attack this HBr to give you a bromine radical along with water. This bromine radical, suppose you have this one, this radical will generate this type of structure and the bromine radical will attack this one. Now your question, now you may ask me also that why it is attacking this carbon, why not the middle? Because if it attacks this one, so you will be left with a 1-degree radical. যদি এই ব্রোমিন রেডিক্যালটা এই মাঝখানকে অ্যাটাক করে তাহলে আমার 1-degree radical পড়ে থাকবে. If it attacks the middle carbon, middle radical, then only 1-degree product will be there. But now as it attacking the terminal alkyl, means terminal radical, you are having a 2-degree radical, which is more stable. Now this 2-degree radical will come in the vicinity of water to give back the OH radical. Okay, so this is the reaction that is occurring. So this is why anti-Markovnikov product is more favorable. Now, why I have used HBr? Because in most of the cases, this reaction for the Br radical is exothermic. Br radical এর জন্য রিঅ্যাকশনটা এক্সোথার্মিসিটি দেখাচ্ছে। Br radical এর জন্য রিঅ্যাকশনটা এক্সোথার্মিসিটি দেখাচ্ছে। কিন্তু আমাদের অন্যান্যদের ক্ষেত্রে এতটা এক্সোথার্মিক দেখায় না। Br এর ক্ষেত্রে the মানে formation of Br radical as well as the reactions after the formation of the radical, that is the addition of Br radical, both are exothermic in nature. কিন্তু আমাদের বাকিদের ক্ষেত্রে কিছু জন্য এন্ডোথার্মিক, কিছু কোনো কোনো জায়গায় এক্সোথার্মিক। This is what is the difference between bromine radical and other. তার জন্য অ্যান্টিমার্কনিকভ রিঅ্যাকশনের ক্ষেত্রে বা খারাশ এফেক্টের জন্য the most important reagent is HBr, means HBr and peroxide. এটা most important reagent. Okay, so but alkynes we cannot directly prepare an alkyl halide directly from any alkyne, because we can prepare vicinal alkyne, but direct alkyne cannot be prepared. One other thing is that if you have a double bond, you can directly add bromine and you will get this. Okay, it will give you this group. If you want to add bromine water, so actually what here you will get, you will get HOBr and HBr. Between HOBr and HBr, HOBr is more reactive, and you will get CH2, CH2, Br and OH. Okay. When you are using HOBr, remember you will have OH minus and Br plus. Okay, you will be having OH minus and Br plus. Okay, so this nucleophile will be OH minus and the electrophile will be Br plus. One will be minus and one will be plus. If it is CH3, CH2, like if you are having this one, if you have this and you are adding HOBr here, so you will be getting CH3, CHOH, CH2, Br. Okay, then you will get this. If you have a triple bond, you can add HBr, but you will get a vicinal bromide. Okay, you cannot get a alkyl bromide or alkyl halide directly from an alkyne. So we will not go for the alkyne. Okay. Next, alkyl halides from alcohols. Alkyl halides from alcohols. So when we are talking about alcohols, a lot of reactions can be stated. What is the first reaction that we will state is that we will start with the Lucas reagent. Lucas reagent is a reagent in which you will have HCl and anhydrous ZnCl2 in the ratio of 1:1. The ratio of 1:1. So what will happen? Suppose you have, yeah, ROH you can write. This is suppose 1 degree. Now you are having a 2 degree and you are having a 3 degree. Okay. You are giving ZnCl2, HCl 1:1. Here also the same thing. Here also the same thing. So everywhere you will get RCl, and RCl. Okay. But this reaction proceeds via SN1 pathway. Okay. All this reaction proceeds via SN1 pathway. And we all know for SN1 pathway, 3 degree carbocation are more stable. So here for this 3 degree carbocation means the 3 degree alcohol will give immediate precipitation. Immediate precipitation. Okay, when they are treated with ZnCl2 and HCl. Okay, this will give precipitation after 5 minutes, and they will take a long time, takes a long time to give precipitation. Okay, it takes a long time. So this is how you can distinguish between the degree of alcohols. If it is 1 degree, you can distinguish between the alcohols in this manner. Okay. Next, in what way can we prepare alkyl halides from alcohols is that we can use like HBr and H2SO4 reflux. Okay. HBr over H2SO4. Same thing, but here you are using a stronger acid. We're getting an RBr. Even if you add HI, you will be getting this one. Okay. So between HCl, HBr, and HI, the strongest acid is, which one is the strongest acid? Between HCl, HBr, and HI, which one is the strongest acid? Between HCl, HBr, and HI, which one is the strongest acid? Hello? Whose bond strength will be lowest? The one with the lowest bond strength will have the lowest pH as well. Okay, so it will be the strongest acid. Here, HI will be that. Okay. Next, we will be using fluorinating agents. Okay, or halogenating agents. Halogenating agents. Who are halogenating agents? PCl3, PCl5, SOCl2. PCl3, PCl5, SOCl2. Okay, these are halogenating agents. Okay, so whenever you are adding ROH and you can add anything, PCl3 or PCl5 or SOCl2, we will be getting RCl. Okay, between PCl3 and PCl5, we can instead of PCl3 and PCl5, we can use PBr3 and PBr5. Okay, that can also be good, but SOBr2 will not be good enough because SOBr2 is it is not very stable. So, but Pi3, Pi5 can also give you the iodo halogens. Okay, iodoalkanes. Now, PCl3 and PCl5 operates via SN2 pathway. Okay, they operates via SN2 pathway, but SOCl2 does not. Okay, but SOCl2 operates via SNI pathway. Okay, if you give instead SOCl2 and pyridine will give SN2 pathway. Okay, so what is the basic difference between this? A chiral alcohol on treatment with SOCl2 will retain its configuration. Okay, a chiral alcohol on treatment with SOCl2 will retain its configuration, but the chiral alcohol on treatment with PCl3 or PCl5 will change its configuration. If that is, if R alcohol is there and you're using PCl3 or PCl5, you will be getting S alkyl halide. Okay. These are called the enantiomeric isomers. R and S are enantiomeric isomers. Okay. R and S are mainly they refer to the enantiomers. Okay. In the nomenclature of enantiomers, we use these descriptors to differentiate between two isomers. Okay. So we will come to it in our upcoming classes. We will talk about the R and S nomenclature as well. Okay. Now, so this is how you can prepare this alcohols. Okay. Next is we are talking about alcohols. The next one will be nothing but ethers. Okay. Alcohol, phenol, and this. We're not talking about phenols because phenols will be talked about for aryl halides. Okay. Now, from ethers to alkyl halides. Okay. So ether to alkyl halides. How to prepare alkyl halides from ethers? So actually, if you have ROR, this is an ether. If you add ROR dash, if you add HI, you will get ROH and R dashed I. Okay. It depends on what is the configuration or what is the degree of this R dashed. Okay. If both are 1 degree, then anybody can be R dashed I or RI, R dashed OH. Okay, both will be formed. But if R is 2 degree and R dashed is 1 degree, then this will form. Okay, if R is 3 degree and R dashed is 1 degree, then also this will form along with the other. But if it is R dashed is 2 degree and 1 degree, then this will form predominantly. Okay. Even if it is 1 degree and it is methyl, then also you will get this one. Understood? In 3 degree cases, SN1 reaction will occur and there we can get the Ri from the SN1 reaction. Okay. So this is cleavage of ether bond. Okay. Next. We will talk about the halide exchange reaction. Okay. We will talk about the halide exchange reaction. So when we are talking about halide exchange, what is the meaning of halide exchange? One halide is being exchanged with the other. Okay, so two types of halide exchange reactions are mostly used. One is Schwarz reaction and the other is Finkelstein reaction. Okay, দু ধরনের হ্যালাইড এক্সচেঞ্জ রিঅ্যাকশন আমরা ইউজ করি, একটা সোয়ার্জ রিঅ্যাকশন, একটা ফিঙ্কলস্টাইন রিঅ্যাকশন। ইথার বন্ডটাকেও ব্রেক করার সময় আমরা দেখি, আমরা ইথারে যখন ঢুকবো, ইথারের ক্লাস যখন করব, সেখানে আমরা আরো বিস্তারিতভাবে আরো বড়ভাবে এই জিনিসটাকে দেখবো, যে হাউ ether bonds are being broken and what are the actual effect of this degree of carbons in ethers, degree of the alkyl groups in ethers. তো আমরা ওইখানে আরো কিছু দেখছি। হ্যালাইড এক্সচেঞ্জের প্রথমে যেটা, at first we have to consider about the Schwarz reaction. So what is Schwarz reaction? It is, suppose you have an alkyl chloride. Now you want to make alkyl fluoride from it. If you want to directly make alkyl fluoride, it will cause a huge explosion. Okay, এখানে একটা মারাত্মক explosion হয়ে যাবে, and that will means it will be a hazard in the laboratory to directly prepare alkyl fluorides, because it will produce RF bond strength is huge, and the reaction will produce a lot of heat. Okay, the reaction will produce a lot of heat, and exothermicity of this reaction is tremendous amount, and it can cause a lot of hazards. Okay, in the lab. So the main reagent for this is Hg2F2. Sometimes AgF is also used to prepare for this force reaction. This is halide exchange. Okay, it can be RCl, it can be RBr, it can be Ri, anything. From there, if you add these things, you will get this. Okay, it will get the fluoride. Next one is Finkelstein reaction. So in Finkelstein reaction, what do we know? We know that lower, if you have iodides, you can use Cl. If you have iodides, you can use Cl or Br to replace that iodine. Okay, Cl and Br can replace this iodine. Okay, but iodine cannot replace RCl. In this case, we will see that the lower alkyl groups, means if you are having RCl, you can make Ri from it. Directly, this is true. Okay, but how to prepare this? You will need a polar aprotic, a highly polar aprotic solvent like acetone, and it should be completely dry. ঠিক আছে? RCl থেকে Ri টা আমরা সচরাচর বানাতে পারি না, কারণ যখনই আমরা জলের মধ্যে বা কোথাও দেব Cl and I is a better living group. I has a better living property. I এর একটা খুব ভালো লিভিং প্রপার্টি আছে Cl এর থেকে অনেক বেশি। তা ও বেরিয়ে যাওয়ার চেষ্টা করবে, ক্লোরিন ওইখানে ঢোকার চেষ্টা করবে। ঠিক আছে, বাট রিভার্স রিঅ্যাকশনটা ইজ ভেরি টাফ। ফিঙ্কেলস্টেন আইডিয়া লাগাল যে এটা কোথায় ভাঙছে, মানে অ্যাকোয়াস মিডিয়ামে ভাঙছে। সো উই উইল নট গিভ অ্যাকোয়াস মিডিয়াম, পোলারিটির সম্ভাবনাই নেই। there is no, we will make polar solvent but not protic. We will make polar solvent but not protic. তাহলে polar protic যদি না হয়, then you will see that RCl will break, but any type of halide dry acetone, we have to use the dry acetone form, means it should be devoid of any type of water. Okay, it should be completely dry. কোনো water molecules যেন না থাকে এখানে, any form of water যেন না থাকে। So after that we will use NaI, the salt NaI. Okay, after that we will use the salt NaI. So NaI in dry acetone, NaI will remain stagnant. RCl will break. Cl minus will attack Na plus, and it will result in the formation of NaCl, which will leave I minus behind. And I minus and R plus will come together and form this bond to give you this ion. So this is what Finkelstein has in it. Okay, so this is the overall formation of alkyl halides. So this is how, these are the methods by which we can prepare alkyl halides. So there are some other methods by which we can prepare haloalkanes. Okay, halo means haloarenes. So preparation of haloarenes. How to prepare? What is haloarene? Haloarene ta ki? A benzene ring with a halogen. This is a haloarene. Okay, so ki kore, how can we prepare an haloarene? First of all, we will use the process which is mostly used in industry. Okay, it is known as Raschig process. Raschig's process. Okay, it is most commonly used in industries, and you will be having two benzene rings, means two benzene, two equivalent of benzene, two equivalent of HCl, oxygen, and CuCl2 at nearly 500 Kelvin temperature to give you two amount of fluorobenzene along with 2H2O. Okay, this is the first process. The next process is from benzene diazonium salt. From benzene diazonium salts. So how can we prepare benzene diazonium salts? আমরা কি করে বানাবো? We will use amine. This is aniline or aromatic amine. Okay, any aromatic amine. And to it we will use NaNO2 HCl at 0 degrees Celsius or simply HNO2. Okay, we will get this benzene diazonium chloride. Can be represented, it is generally represented as N2 plus Cl minus, and it looks like this. Okay, this nitrogen which is between the outer nitrogen and the outer ring, benzene ring, has the positive charge. Okay, so this is the reaction. Okay, now if you use benzene ring, if I use benzene ring, sorry, benzene diazonium ring, and add CuCl over HCl or CuBr over HBr, anything, we will get Cl, and this is known as Sand-Meyer reaction. If the same thing is repeated but not with any salt of copper but pure copper, okay, over HCl, and you get the same, you will get the same result. This has been done by Gattermann and is known as Gattermann reaction. If you use aqueous Ki and warm the mixture, warm the solution, just heat the solution to a little bit, you will get iodobenzene, but this is not any name reaction. Fluorobenzene. In order to prepare fluorobenzene, you first have to use NaBF4 and heat the mixture. We will get from here N2 plus BF4 minus. Now hit for a prolonged period of time, we will get a fluorobenzene, nitrogen gas will move out, and BF3. Okay, this is known as Ball-Schiemann reaction. Okay, this is the preparation of fluorobenzene. Understood? This is the preparation of fluorobenzene. So is there any other method to prepare this type of halobenzene? Yes, there is some other method as well. That is known as direct halogenation of benzene. We will use Cl2 in presence of FeCl3. These are the reactions that we have learned in electrophilic substitution reactions. This is electrophilic substitution reaction. Okay. Even you have to use Br2 in presence of with Fe, only Fe. At first FeBr3 will form, then the reaction will proceed as it is. For iodination, iodine is itself it can form an electrophile by itself. If you add some acid like HiO3 to it, you will get direct iodination. Okay, so these are the few common methods by which you can prepare. Now, we will prepare both haloalkanes and haloarenes from acids. Okay, we will prepare haloalkanes and haloarenes from acids. Actually, from acids, which what we are going to do is that we are going to prepare it with the Hunsdicker reaction. Okay. It is known as Hunsdicker reaction. Understood? So, can you tell me what is a Hunsdicker reaction? Anyone? Hunsdicker reaction. The carboxylic acid RCOOH when treated with AgOH or Ag2O, it will give you a silver salt of this fatty acid. Okay, silver salt of fatty acid. Okay, silver salt of this fatty acid. Now you just have to add Br2 over CCl4. Okay, remember to use CCl4 over Br2. Why CCl4? Because we need a solvent which have zero polarity. CCl4 is a completely non-polar solvent. Why CCl4 is completely non-polar solvent? Because it has zero dipole moment. Because it has zero dipole moment as it is perfectly hybridized molecule. So you will get from here RBr, CO2 and AgBr. And you can see that this R can be anything. It can be a benzene ring as well, or it can be an alkyl ring as well. Understood? Anything is possible for this R group. The other form of reaction is when you have an activated methyl group. Okay. When you have an activated methyl group. So activated methyl group can be of two types. Either you are using an alkyl group which is attached to an vinyl group. This is known as an allyl group. Okay. Or you want to use it as a benzyl group. Okay. These two are activated methyl groups. Okay. These two groups are known as activated methyl groups. Now you can ask me why this is known as, why these are called activated methyl groups. The answer is these are actually, these can perform hyperconjugation. Okay, activated methyl groups. They can perform hyperconjugation. That is why they are called activated methyl groups. So any one of them, if you use NBS, okay, if you are using NBS, what is NBS? NBS is N-bromosuccinamide. This is your NBS, N-bromosuccinamide. It is the acid, means it is the amide of the succinamide, bromoamide of the succinamide. Okay. So if you add this, you will get CH2, CH, double bond CH2, and you will have a Br here. Here also you will have a Br, CH2, and a benzene. Okay, so this is how you can prepare the halogens from an activated methyl group using NBS. Okay, sometimes nowadays NCS is also used in chlorosuccinamide to chlorinate these things. Okay, so this is the main, the second part of our chapter, which is alkyl and aryl halides. So we have discussed about the different methods by which we can prepare a haloalkane and a haloarene. In the next part, আমরা যেহেতু পুরোটা haloalkane and haloarene এর প্রিপারেশনটাকে কমপ্লিট করেছি, আমরা next part এ গিয়ে, in the next part we will learn about the reactions and what type of questions, essential questions are there for our JEE Mains, JEE Advanced, NEET, as well as our boards. Okay, till then we can stop here and